this is what I'm going to cover today. So far we have seen big data use cases in a big way, right? I think it is going to affect your daily life and the most unexpected ways. So we've seen those use cases, but today we are going to do nuts and bolts of what we want to do, right? Nuts and bolts of data science. So we're going to cover how we can use Hadoop for data extraction and data processing. And then further, whatever you extracted, how do you build some models, right? Machine learning models or models for data analysis on the top of the data that you have extracted. And then how do you analyze the data, right? So this is all done. I have a team of about 3 people who have done for about 3 months, actually 2 months. Okay, we did this whole thing in 2 months. So what we did is instead of taking data, because nobody is ready to share big data. I know this is small data right now what we are analyzing. No one is ready to share big data. So we took the data set from Yelp. Okay. So this is the company called Yelp. It's based out of Phoenix, Arizona. What they do is simply rate businesses, right? Rank and rate businesses, and users can actually submit reviews. Users can submit reviews about these businesses, right? And they have published this data set. So this data set is about, let me show you, yeah. So here is the data set we have. So we started with this data set. So what does this have? This has about 15,000 businesses that are listed in this website. So just like just like India we have Just Dial, or you have seen TripAdvisor, right? Those all the businesses are listed there, people who use those businesses, and then they update reviews, or they basically review that particular service. So that's how it is being built. So we have about 100,000 roughly business attributes, right? So if you're looking at a restaurant or something like that, then you will say Thai restaurant, you offer lunch, you offer breakfast, or you offer dinner, things like that. So those are all the business attributes. So all kinds of businesses are covered, not just the restaurants and things like that. So then they also have about 11,000 checking sets, right? This business, right? Which hour of the day, how many people got checked in, how many people have been used. So this, even though it's useful here, we are not used in checking data sets. And there are about 70,000 users that are exposed. It's just a small fraction of what they have. This data is just a very small fraction of what they have, right? Because they started in 2005, and it's almost 8 years. There are humongous data about businesses and users. And then, of course, the social graph, people will say credit, but they are not given the social graph data. Then you have about 200,000 reviews, right? People actually go for a restaurant and say, okay, I love this food, or the ambience is great, or this is too good, but the price is too high. Things like that. So it's a review a particular business, a restaurant in this case, right? So that is this is the data that we took. And then there is also a challenge, right? So there are challenges like, okay, so can you predict, right, how many reviews are going to come for my business next month? Given this data set, right? So let me go a little bit detail. Can you predict how many people are going to review for this business given the past 5 years data? So the business has categories, the categories have the business has reviews, and users have the reviews and things like that. So that is some of the problems that we'll discuss today. But before I get, so again, just a quick overview. So Kaggle is another website. They run data science competitions, right? You can also become data scientists by participating in the competition. So some of the things that they run on this data set is estimate the number of useful words a review will receive. Right? How can I predict? Suppose you do a review. You might see that what is the value of predicting the number of votes for a particular review. It's a very trivial thing, right? Who is interested in predicting the votes for a particular review? But it's actually potentially in social media has a lot of value. It's almost like how many likes that your article has. Right? Recently I've seen Naidu suddenly with TDP's Facebook likes have gone up by 100,000 or 1 lakh. It looks like they all came from Turkey. Right? So it's interesting. So you pay for your likes. So there are some places, there is also another competition where people are hiring resources where they can write reviews. You're seeing in Amazon or any of these websites, right? right? There will be proxies, right? If you want to go buy a car, like Costco, which I bought, I was looking at the reviews. I see some good reviews, so I can immediately find out, this must be a guy, maybe sales guy writing from Ford, right? So you should be able to discriminate between the fake reviews and non-fake reviews. Right? That's a very difficult problem. Because just by looking at the review, versus looking at the text that they have done, you should be able to discriminate. So there's another combination that's not going on here. That's a more complicated model. Then, so sometimes you want to recommend, right? I go for restaurant 1 or restaurant 2, then you recommend your other friends, right? What is the best restaurant in the town or in that particular area. So personalized recommendations are also there. So participants will be able to create a model to predict the rating of a user who doesn't use business. So what would happen is how much a user can rate a business, how we predict it. So things like, so we're going to cover the nuts and bolts of these use cases today. Alright, so the general feeling that from the last discussion we had so many faculties of science and technologies that are intertwined to become a data scientist, right? But it's not so. So if I have become a data scientist, if I am, you can also become a data scientist. You don't need to have such a vast amount of broad technology areas. So people who are winning in carrier competition, they are not from Stanford or MIT. Right? They are people like us. They are not from any Ivy League education or a PhD instead. There are some people who are PhD, but they are not from any of those. Many of the data scientists who have won so far are self-taught. Right? So this gives me a positive, or this gives me a good hope that one day I can also become a good data scientist. Okay? How to do it? Right? Golden days, you have lots of lawyers from IBM, and then you have PhDs from IBM. They build huge mathematical models around it. So you cannot understand this. You just pay money, we will do it for you. Right? And then you have deep neural network, deep learning techniques where how is this guy is going to be nailed down, right? What is he going to invest on? Where is the home or not? How many cars he has got? Where is he going? How many properties? He can nail down every guy or every business to the utmost detail so that your risk for your business or risk for the banks can be minimized. So that requires deep learning methods, right? So older days, only big companies can take this technology. Today, that is not so, right? In Canada, you put a competition and the competition is lasting for about 3 months, you put $3,000 and you get the best solution. So things have become much cheaper, it has become more affordable now. So small and medium business company like mine can actually pose a problem and I can get the best solution across the world using carrier competition. Okay? Again, the vast majority of the winners, these carrier competitions are they're not using huge servers, they're using simple laptops or a desktop with a small piece of software called R and Python. Okay, so that means you could do this. So R is free, Python is free, you can download it and start working. And then later on, if you want to refine your model, on big data, then you always have Amazon. You pay for $50 per hour, get 20 computers, run for 2 hours on the big data, and then your algorithm is refined. So you don't have to spend huge amount of resources to do data science today. And then carry most of the problems that people are attempting are not that complex. They're very simple, like for example, predicting how many useful words can a review have. It's a very simple problem. So again, there are certain simple things like, for example, people who like Lord of the Rings movie are almost all the time are going to like Star Wars. Like things like that can be concluded very easily. And then of course, some of the existing scientific and industrial benchmarks in terms of predict are beaten because you have a lot of people working together to do an evaluation of it. Okay? So the whole point that I was trying to tell you is that data science is real today, you can do it as of now. Okay? It doesn't have to be, you have to just put persistent effort for a longer period of time, then you can become a data scientist. That's the essence of this few slides that I wanted to convey. Then you might also say what are the top 10 algorithms that people are going to use. Top 10 machine learning algorithms. There are just 10 handful of them. Right? So if you learn top 10 algorithms, then you can solve 80% of problems. So that's what it is. But in Cardio, just 3 algorithms are mostly used. One is the ensemble of decision tree, it's also called So we'll discuss briefly what these algorithms are. So again, you can go into deep mathematical equations and then confuse you or make sure that this talk doesn't make sense. But I can also do this little bit of layman's view. Right? I'm trying to simplify. Okay? I'm trying to give you a layman's view what these techniques are. Okay? So then also like one of the things that you need to be a good data scientist. Right? You need creativity. So you have to think in multiple number of ways. Right? Just say one way of thinking is not going to solve the problem. So you have to be creative. Then the most important thing is in data science or in analyzing these problems is feature engineering. Right? Feature engineering means you have a data set. For example, in the data set that we have seen, we have business number of businesses, about 15,000 businesses. We have 300,000 reviews. Now, if I want to predict this particular business, X business, there will be 20 reviews or 100 reviews coming next month. Then how do I extract enough data out of this existing data and then try to conclude maybe there are 1,000 reviews that are going to come for this business. Right? So if actually all the restaurants are full and a lot of reviews are happening, I can say that if I end business, like an entrepreneur like me, if I end business, if I start a business, restaurant business, somewhere in the corner, I can say because these other people are getting so many reviews, which means each review amounts to a customer. Which means that there could be a sizable business for me in around that school area as compared to other areas. So you can predict, it's almost predict, hopefully. Even if you predict 40%, that's a very good percentage. So you also need multiple ways of thinking about the same problem. Right? Same problem. There's a saying that if you beat the data too much, right, it will give you the answer you want. So don't beat it too much. Don't think too much about data science. Right? In fact, it's same for our lives also. Right? If you think about a problem too much, right, it will answer what you need. So data is dangerous too. So again, there's another topic that we discussed. You have to be a domain expert, right, in order to be a data scientist. It's actually not so. So if you know top 10 algorithms, you can solve about 70 to 80% of the problems. And you don't need to be a domain specialist. You just need to understand the data and what role it plays in predicting some anomalies or predicting unknown variables. Right? So a good data scientist doesn't need to have a huge domain experience. You can always get help from other people to just get the basic understanding of the data, but it doesn't need to be a domain specialist. So you can do machine learning in supply chain, you can do machine learning in NLP, you can do machine learning in many number of domains. Right? So now let's get into a little bit detail, more detail. Right? So this is the data that I have got. This is structure of the data I have got. Okay? And this is about the reviews. So a review, basically have a type what is a review. For which business the review is being given. And what is the user ID? This is encrypted so that you don't see it. Which user has actually done this review. And the star rating counted to half stars. Right? So people do rate these reviews. Okay? This star rating is calculated. And then what is the actual review? So the actual review will be something like this. Food is great, ambience is awesome, right? Value for money. Right? This is the review that one restaurant has got. So then you have a date of the review, and then people can vote. This review is useful because I really like this review, and because of this I go to this restaurant. I really like this review on the mobile, so that's why I bought this mobile. Something like that. So you get votes like, okay, this is a cool review or a funny or not. A useful review. Okay? So if I have so much sufficient data, like 300,000 reviews are there for about 15,000 businesses, and there are about 11,000 categories of business that they have. Now, if I just say, let me do only for restaurant business, right? If I have to find out, if somebody let me say I did a post this review, can you predict? Can you predict how many votes I'm going to get with the data? So that's one problem that we'll try to address today. So this is the business structure. So they have purposefully included latitude and longitude. So because you can do temporal and spatial analysis too, right? Which means that in around this location there are other competitive businesses, and if you look at all the reviews, right, we can infer something. Right? Around that latitude and longitude. So other than this, you have state, city, you have full address, and you have neighborhoods here. So especially if you have some food court in our mall, right? People who go for shopping, eventually they are doing something, right? So there you can see that the latitude and longitude for a particular restaurant does matter a lot. Right? If it is inside a mall, then probably there are more reviews, more customers. So this is again user data. What kind of data that the user has? User has basically a user ID and a name, and how many reviews that he has done. Some people are very active. Right now, another problem, right? Suppose I have a business, trusted business license or something. I want to know more about my users. Right? If I want to know more about my users, then I should actually go and see what reviews they are giving. I want to find out, okay, so this user, is it a happy customer? Or he is a regular customer? Does he come regularly on Thursday? That's the process, right? Or he is one angry customer, he came and gave 2 reviews and he forgot about it. Right? Or when was the last review that the user recommended? What impact it has got on my current business? Right? So what it means is that can I cluster the users into some users like, okay, the regular customers, very often they are coming to my restaurant. There are some customers who come only once in a while. There are unhappy customers and very happy customers. There are some basic customers who are like on the way they pass by and then have died in my restaurant. Can I cluster the users, right? So now if you expand this problem a little bit, if you go to the CRM database, right, a mobile website by Samsung S5 or S4, and I want to see who are the happy customers, who are the unhappy customers, and if whoever is unhappy, what is the problem with that? I can immediately cluster these users, and then I can focus on users that I'm interested in. Right now, it's all about relationship again, right? If I know this customer very well, I can always go to my financial database and say how much revenue is bringing in. Right? In that case, you know that this guy is very important, it's very for my business, because 30% of my business comes to him. For example, Wipro, right? Infosys. But 10% of the business lies on GE. Right? So if then I should make sure that GE is always happy with me. Right? So then the CRM database is very useful. Similarly, let's say CRM database is there. I have customer reporting about car defects for a bench. So the bench would like to know what kind of parts have been ordered frequently through the CRM database. Right? So then you can find out okay, this particular part. This is not available in your structured data. It's not available in online transaction database. It's most of the time it is part of the CRM data, which is unstructured data. So in that case, you want to find out how many times, what kind of problems are coming. Can you predict in that case how many such problems will come? Then if some such problems will come, then how much of revenue I'm going to lose? Right? So then come back and say this is the bottom line for my business. So if you do very interesting things, and there is no limit for all kinds of things that you can do with big data. As I said, you have all kinds of data coming in, but again, it's always easy to confuse. So in our case, right, for the last 2 months, whatever we got on this data, we got the raw data set, we put it to Hadoop file system, and then we use Hadoop for processing. So we have written almost like half dozen to a dozen manual programs that takes the data and then spits out interesting data from it, whatever I'm interested in. So what kind of interesting data I would like to know? For example, this business has how many reviews, and what is the number of monthly reviews for this business in this particular category, things like that. So I can spit out whatever kind of data that I need within the existing data, so that I can do summing, I can do modeling. Okay? That's the idea. So because of lack of time, I'll skip through this, okay? So that you understand the whole essence rather than the actual statistics. Because the whole thing, that's what we did. We took about 2 months. The whole thing is packed in a VM. Right, and then whoever wants, any customer wants to see, they will just take this VM and give it to him. Right, he will be able to know all these things, whatever we did, in a very simple 6 GB VM that we have created. For doing big data, those days you need people from IITs, some guys who are very mathematical, or who can write best of data, who also can do multi-threaded programs that avoid deadlocks. Right? So then if you have so many computers, 10% of the computers fail all the time. So then you need a program which can actually afford to fail and still be successful. So Hadoop is great because it addresses all these problems in one shot. And number 2, a 2-year experience Java can actually write a distributed program, which before Hadoop it was a big task. Just to understand the framework, right? To understand message passing, to understand multi-thread program, to understand the data, to understand how the data workload is being distributed, right? Workload has been distributed across several computers, and then once the work is done, it has to be aggregated. All the way to code as part of a program. Now with Hadoop, that's not the case. Right? I just write two simple functions called map and reduce. My job is done. So that means that with 2 to 3 years experience Java can write a distributed processing program and can analyze huge amount of data. That means cost of processing big data has gone down quite heavily, hence big data is becoming more prominent. So Hadoop is a distributed operating system. It just gives you simple tools, a facility where you can start processing huge amount of data, where you don't have to worry about how to distribute the load, you don't have to worry about what happens when a network fails, you don't have to worry about what happens when your computers fail, things like that. Okay. So again, you skip this. Okay. Again, there is a huge ecosystem. Right? Hadoop alone cannot satisfy all the requirements. This is the ecosystem that we need to make sure that you can do process large amounts of data. Right. So we're not going to detail. There's more interesting parts that are coming. So what we did is a block diagram of what we did for Yelp data set. So we took the Yelp data set here, right? And then we copied to HDFS, Hadoop file system. Hadoop file system will make sure that my data is always there even if I have to pay comments. Right? That is why Hadoop file system. This Hadoop is basically distributed file system. So there will be at least 3 copies of the same data. Right? One copy may be somewhere in US, one copy here in my local machine, another copy in my other data set. It's possible that way. So it makes sure that my data is secure or is safe. I don't lose the data. So then I do a lot of processing of this data, right? And then I can use Hadoop, which is a plain vanilla Apache Hadoop, or I can use a commercial distribution like Cloudera, or I can also use a tool called Hive, right? And then for tying all these workflows, tying all these map reduce tasks together, I have a tie-up. I have a small stitching software called Lucy, which gives you a workflow for managing all this map reduce tasks. So after all this, I get some data. Right? This all I'm running on a desktop because I don't have huge data. We have only 300,000 reviews, about 15,000 businesses and 70,000 users. So that for that desktop is good enough for me. So then whatever data that I got from my desktop, push into R. R is a statistical piece of software. You can do machine learning, you can do statistics, a great piece of tool. So you can always use that. And then from R, I do my machine learning analysis. Right? That is what we have done. So traditionally what happens is this data may be coming from huge databases, right? Push it to the Hadoop file system. So the reason why Hadoop file system is used because the cost per terabyte of storage is reduced drastically. Then once you have this, you do some processing, push it into another database here, and then you expose your dashboards to web. That is how the system works. We have exactly done this, except that we did a little detour here. Instead of going to scoop and then putting into DB, we just push the data into my desktop and then use the R to analyze the software, analyze the data. Okay? So then finally from R, I should be able to get my analysis on a website, or I should be able to make a nice presentation to my people who are going to pay for the work. Okay, so this is the block diagram of how we process the data. So end of the day, if you take any data science project, right, 80% of the time it is about engineering, data engineering. You have to just mash up the data, right? Get data from different sources, right? And then try to prepare the data so that the analyst can make some sense, or so that the data scientist can operate on the data. So if you take 100 hours of data science project, 70 to 80% of the time is all data engineering. So we still have jobs. So job is to be happy. Right? So it's not just that data science will have a job, but I still have a job. Right? Because 80% of the time is all about writing manual-based tasks, doing this, I don't want this zip code, I want business name, I don't want ID, I want city as part of this. So there's so much of vocabulary about the data. Right? For that to prepare, it's not easy. It takes time, it takes effort, it takes long hours. Right? So all that good work for dog work is done by Hadoop in my case. So we use two strategies. One is we took the data from the Yelp data set, and that is in JSON factor, JSON format. Right? JSON is highly structured. It's easy to understand and visualize. So we directly map to Hive tables. So some of you who have done Hive, we directly map to Hive tables. So once it is mapped to Hive tables, then I can use standard SQL tools right? Which 80% of the business analysts know those tools. They can just issue SQL queries and then they can understand or they can query the data. So I don't have to do any processing. So that is one way. The other way is that we have to write, in some cases, a complicated mathematics task. So that I will be able to join multiple data sets together and I should be able to get the data I got. For example, so the kind of data that output that we got, right, if you look at this. So end of the day, I got a spreadsheet model. For example, let's say this is a time series modeling I have done, right? So what it means is, if you see here, so I have a category of business, I have a review count, I have a year, and which month, how many reviews have happened, and how many stars, how many 1 stars he has got, how many 2 stars he has got, how many 3 stars, 4 stars, and then what is the stars on average. And then further, I can also say, in this month, out of those 30 reviews, what is the sentiment? Right? Is it positive sentiment, negative sentiment? So this is the data that I got from the data set that I have shown you earlier. Right? So the data set that I got is JSON, but here is pretty much a spreadsheet model. So once I have this data, I can load this into any table, right? And then can do SQL query. Or now, this is my fundamental data that data scientist needs. Right? Once I have this is also called as feature engineering, because from that data, these are the features that I am interested in. Right? So a restaurant in certain location, right? Given this data about all the businesses in that area, right? So I have a time series data, which means that starting in 2005 till 2014 April, I have all the reviews, right? Who has done what reviews, and every month, every year, every month, how many reviews have come, and out of those reviews, how many are positive, how many are negative, how many are neutral. So all the data is with me. Now, given this data, time series data, can I predict how many reviews are going to come to my business next month? Or how many reviews are going to come to my business next 6 months? So that I can find out, I can roughly, hopefully, or almost, I can find out whether my investment is good revenue for next 6 months or not. Right? Does it make sense?